So till now we have discussed reference frames moving with constant velocity, and we have seen that all reference frames moving with constant velocity are inertial reference frame, and Newton's law of motion are applicable in all inertial reference frames. And to observe the motion from a reference frame which is moving with velocity v, we have to reduce the v velocity of reference frame from the velocity of object which is under observation. So that we have studied till now. Now we will discuss another very important concept which is also relativistic concept. That is the concept of pseudo force. Concept of pseudo force. This is also relativistic concept, but this concept brings forces in the picture. This is analogous to the concept of which we have discussed till now. Here the difference is that earlier our frame was moving with constant velocity. Now our frame is moving with constant acceleration. So pseudo force concept comes when we discuss the frames moving with constant accelerations. For constant acceleration moving frame, pseudo force concept is used to simplify the problems. Problems are greatly simplified by the pseudo force concept, which we are going to discuss, and it is analogous to our previous discussion, that where frame was moving with constant velocity, and here frame is moving with constant acceleration. So let us discuss. So this is one reference frame x, y, z, and this is another reference frame z, and this frame is moving with acceleration a. This is O and this is O dash. So this frame is moving with acceleration a. So at t is equal to 0, O dash, both were at same position. So this is the point P, and this point is also moving, and the coordinate of this point x, y, z are given as t square, 2tq, 3t. Just for example. So this point is moving. After time t, the coordinate at the time t is equal to 0, this point is located at origin, and this point is also located at origin. At time t, this point has reached from O to O dash, because this frame is moving with acceleration a, and this point P has moved from O to P. Let us say it is point A, and its coordinates are t square, 2tq, 3t after time t. So we have to find the relation between acceleration of this point from this frame and this frame. So let us come to this frame. For this frame, x is equal to t square after time t, y is equal to 2tq, and z is equal to 3t. For this frame, position of point after time t is given by coordinate x, y, z, which are function of time. So we can say in this frame, acceleration in x direction, that is ax, is equal to d2x over dt square, which is 2t, and second derivative is 2. In this frame, acceleration ay is d2y by dt square, and this is 6 12t. You can easily find derivative. And Az is d2z over dt square is equal to 0. So in this frame, acceleration of this point in x, y, z direction is given by this point. So these are expressions for accelerations. Now we will find acceleration in this frame, new frame. X dash, y dash, z dash are coordinates of this point in new frame. So let us find y dash and z dash. First, y dash, this frame is moving in x direction. So in y direction, coordinate will be same as coordinates in this coordinate axis. Now in x direction, as we have discussed earlier, this point in x direction, earlier this point was at origin, so this x coordinate was 0. So in time t, this point in x direction has travelled this distance, that is x. The coordinate of this point related to this frame is x, which is nothing but distance of this point from this axis. Similarly, this O dash point was here, so this has travelled a distance. By Newton's law of motion, you know S is equal to ut plus half at square. So this point O dash was moving with acceleration a dash, and its initial velocity here was 0. So OO dash, S is equal to OO dash is equal to half a t square. So this distance is half a t square. By Newton's law of motion, you can easily find this distance. So x dash, which is coordinate of this x coordinate of this point related to this frame, will be this total distance, that is x minus OO dash, that is x minus half a t square. Now we will find acceleration in y and z direction first. A dash y, let us say a dash y in this frame, dt square d2y dash is equal to, as y dash is equal to y, d2y over dt square, d2y over dt square is 12t. Similarly, z dash, acceleration in z direction, d2z over dt square, z dash, and z dash is equal to z, because in z direction and y direction its acceleration is 0. So y and z coordinate in both axes will be same, is equal to d2z by dt square, and this is 0. Now acceleration in x direction, ax dash is equal to d2x dash by dt square. So let us differentiate this. First differentiation will be dx over dt. This can be written as d dt of dx over dt minus at. Differentiation of this 2t into half, that is 2 and 2 will cancel, only at will remain. And this can be written as d2x by dt minus a. So you can see that acceleration of this particle in x direction relative to this new frame is acceleration in old frame, that is d2x over dt square. This is acceleration in old frame. In this frame, this minus a, and a is the acceleration of this new frame. A is the acceleration of this new frame. So this is analogous to our earlier discussion where velocity in new frame was coming as v dash x, we have found dx over dt minus v. In our earlier discussion, for frame moving with constant velocity, new frame, velocity in new frame for an object was velocity in normal stationary frame minus velocity of moving frame. Similarly, acceleration in this case where a frame is accelerating, acceleration in this frame is acceleration in stationary frame minus acceleration of this moving frame. So you can say that acceleration in new frame is reduced by acceleration A, which is acceleration of moving frame for a point moving with its acceleration relative with its unique acceleration relative to stationary frame. So this is for one direction, but I have already told you these are vector expressions and they are valid for all directions. This is only for one direction because only for explanation purpose, to make the explanation simple. But this is vector equation, so acceleration, I can say this general form of this vector equation is a dash is equal to f minus a, where a dash is acceleration of a particle moving in this new frame, f is acceleration of particle moving in old frame, and a is acceleration of this particle. So you can say if acceleration of this frame is a and a particle in this frame is moving with acceleration f, then acceleration in this frame will be a dash, which will be f minus a. And that was for only x direction, but this is vector equation and it is true for all directions. So acceleration of a particle in this frame a dash will be f minus a. Here f is acceleration of particle in this frame and a is acceleration of this frame. So acceleration of this frame will be reduced by original acceleration of particle when the motion is observed from this new frame. Let us imagine a particle of mass m, is there, and a force F is applied on this particle. A particle having mass m and a force is applied F. So in this frame, stationary frame, its acceleration F is equal to F by m. F is the force on particle. Now we want to observe from this frame there, which is moving with acceleration a. So from this frame, acceleration a dash will be f minus a is equal to f by m minus a is equal to f minus ma by m. So this new acceleration, you can write f minus ma by m. So when we observe motion of particle from this frame moving with constant acceleration, that is a dash, then we have to apply an imaginary force ma, where a is the acceleration of this moving frame and m is the mass of the particle, and f is the real force which is acting on the particle. So when we want to study motion of particle from this frame, which is stationary, then we have to consider only f, and we will find acceleration f is equal to f by m. But when we find acceleration from this frame, then we have to apply a force on particle minus m into a, that is opposite to this force, opposite to motion of this accelerating frame, minus ma. Then we will get acceleration of that particle in this new frame. So this minus ma force, which is not actually acting on the particle, this force is not actually acting on the particle, but we have to introduce this force in its motion, equation of motion, just by the virtue of motion of this accelerating frame. This motion of accelerating frame is causing creation of this ma. This ma in opposite direction of this moving frame is called pseudo force. This is not actual force, but this you have to introduce in the vector equation, motion equation, to find the motion of this particle, a dash, which is acceleration from new reference frame. So this ma is called pseudo force, and this force is by the virtue of accelerating frame. So one more important thing you can see here, Newton's law of motion are not applicable in this frame, because here acceleration of particle is not f by m, it is f minus ma by m. It is after application of virtual force. So this is called non-inertial frame, non-inertial frame, because this frame doesn't obey Newton's law of motion. Newton's law of motion cannot be directly applied in this frame, which is moving with constant acceleration. Hence, this is called non-inertial frame. Even though no actual force F is acting on the particle, still you will find minus ma force. Even if F is 0, minus ma force will be experienced from this frame, and a acceleration of this object in opposite direction will be observed by an observer sitting in this accelerating frame. Hence, somebody will say there is no force on this particle. Still, observer sitting in this accelerating frame will observe acceleration minus a. If the acceleration of this frame is in this direction, then acceleration of particle will be in this direction, opposite direction, will be observed by observer sitting in this accelerating frame. Hence this is called non-inertial frame, because it doesn't obey Newton's law of inertia. Even though no force is applied, still in this frame particle will be observed as accelerating. Its position will change, its motion will change, which defies the law of inertia of first law of Newton. For as per the first law, the motion of particle will remain unchanged without any external force. But in this frame, which is accelerating with acceleration a, even though no force is applied, still acceleration a will be observed for a particle in negative direction. Hence, the law of inertia is not applicable. Particle's motion velocity is changing without application of any force. Hence, Newton's law of motion, we can say, are applicable in all inertial frames, but they are not applicable in non-inertial frames. For non-inertial frames, we have to insert a pseudo force, that is m into a, where m is the mass of object and a is the acceleration of moving frame, and this ma force will have direction opposite to the direction of acceleration of moving frame. It is analogous to the velocity concept, where velocity we were applying on object which was opposite to the velocity of moving frame. Similarly here, force will be opposite in the direction of moving frame, accelerating frame. So this is the concept of pseudo force, and pseudo force is generated because of, by the virtue of acceleration of a frame, acceleration in a frame. That's why pseudo force is generated. So now pseudo force, we will discuss pseudo force in circular motion. Here we have discussed linear motion. Pseudo force also exists in circular motion, and in circular motion this pseudo force is called centrifugal force. Force is same, that is virtual force, and we will say how this force is created in circular motion. So this is a table, and this is the center of this table. Center of this table, and by a cord, a mass M is tied. And this table is kept horizontal, and this table is rotated with constant angular velocity omega. In horizontal plane, this table is rotating at constant velocity omega. So this particle M is also rotating with constant velocity omega. So we know that this particle will have velocity equal to tangential velocity. At any instant, if the radius is r, the velocity of this particle v will be r into omega. Its magnitude will remain same throughout the circular path. But we know at every instant when this particle reaches here, its velocity is here in this direction. This particle reaches here, its velocity in this direction. Its magnitude is same, but the direction of velocity is changing. As the direction of velocity is changing, hence we can say that the particle is accelerating, because acceleration is defined as vector v2 minus vector v1 by delta t. So between this and this point, this is vector v1, this is vector v2. So this vector v2 minus this vector v1. So v2 minus v1 is this vector. It takes time t, delta t. So acceleration is this vector v2 minus v1 divided by delta t. So this particle is continuously accelerating. It is not, even though its velocity appears to be constant, but its direction is changing, and by virtue of change in direction, this particle is accelerating. And we know that the acceleration is omega square r. Magnitude of acceleration is omega square r, and the direction at any instant is towards the center of this rotating this circular path. So every instant of time, every time this particle has acceleration A is equal to omega square r towards the center. So this particle is accelerating. Now suppose somebody is sitting in this frame, this observer is sitting in this frame. So you can say when observer will sit on this frame and the relative motion between observer and frame is zero. Relative motion between observer and frame is zero, then observer will also have acceleration omega square r. As observer has sit on a accelerating frame with acceleration omega square r. Hence, to study the motion of this particle, he has to apply a pseudo force. And what is the pseudo force? M into A minus M into A. M is the mass A is the acceleration of reference frame. So this acceleration is omega square r, and minus sign says that pseudo force is opposite direction, opposite of acceleration of accelerating frame. So this frame has acceleration towards center. Every time this frame has acceleration towards center, omega square r. Hence the pseudo force will have direction outward from the center. Pseudo force direction is always opposite to the direction of acceleration of frame. So this frame is accelerating in this direction, hence pseudo force on this mass will be towards this, have magnitude equal to m omega square r. M is mass of this particle, omega square r is the acceleration of this rotating frame, and this direction will be towards outward from the center because the acceleration of frame is towards the center, and direction of pseudo force will be opposite to the direction of acceleration of this frame. Hence, when we will observe from here this particle, then we have to apply a force m omega square r, that is pseudo force. And after applying pseudo force, we can apply Newton's law of motion to understand the motion of this particle. So now let this particle m, how much force this is experiencing. One, it is experiencing pseudo force outward from the center. Let there is tension T in this cord. So this m is, this table is horizontal. So this gravitational field downward and reaction of the table upward will balance each other. In horizontal direction, this particle mass has pseudo force m omega square r and tension T and m omega square r outward. And from this frame, observer says that this particle is stationary because this observer is also rotating with this frame, accelerating frame, and then he will say this particle is not changing its position. Net force on this particle is zero. So the net force, that means actual force, which is T is the actual force which is acting on this particle, and a pseudo force m omega square r. So for this frame, particle is experiencing T and m omega square r, and observer says particle is at rest. This means T is equal to m omega square r. That is the use of pseudo force in circular motion, because this observer says that particle is at rest, hence summation of all forces on this particle is zero. So how many forces this particle is experiencing? One is T, that is real force exerted by this cord, and second, by virtue of acceleration of this frame, m omega square r. After applying m omega square r pseudo force, centrifugal force, which is also called centrifugal force, after applying pseudo force, this observer can apply Newton's law of motion on this particle. That is, summation of real and pseudo force will be zero because this observer observes that this particle is not changing its position. It is stationary, and summation of all forces will be zero. So one force is T, that is actual force. One force is pseudo force by virtue of rotating frame. After applying both these frames, both these forces, Newton's law can be applied in this rotating frame by this observer. Hence, we conclude that T is equal to m omega square r, because in this frame, this observer sees that this particle is stationary. So that was the concept of pseudo force in rotating frame, and this pseudo force is also called centrifugal force for rotating field. Similarly, we will take an example of linear motion, where pseudo force is applied for a accelerating frame. So just take an example. Let this is a lift, this is the ground. There is G is equal to 10 meter per second square. Let this weight is kept of mass m on the floor of this lift, and the observer is sitting inside the lift, and the lift is accelerating with acceleration a upward. So what will be the mass weight of this block inside the lift? That is very simple example, which I will explain with the help of concept of pseudo force. Very simple example. So this observer want to see what is the weight of this mass, block of mass inside the lift, which is accelerating upward with acceleration. Uniform acceleration due to gravity is g, that is 10 meter per second. So when we are sitting on this reference frame, that is on ground, from ground we see this object and say that this object is experiencing a gravitational field mg, and this object is experiencing a reaction force n. Now to understand the motion of this block, make the motion of this block simple. The observer shifts his frame from ground to inside the lift. Now I am sitting inside the lift. I see this object as stationary relative to me. This object is stationary. But I know that I am sitting in a accelerating reference frame. Hence, to study the motion of this particle, this block, as I am sitting in the accelerating frame, I have to apply a pseudo force on this mass, because I have changed my frame from ground to an accelerated frame. Hence, I have to apply pseudo force on this particle, except actual force acting on this particle. Actual forces which are acting on the particle will have to be considered. After considering the actual forces on this particle, I have to consider additional force, which is pseudo force, because I am sitting in a accelerating frame which is accelerating with the acceleration a, and by virtue of this acceleration a, it will generate a pseudo force which I have to apply on this mass. Then I can apply the Newton's law of motion on this mass. So let us make free body diagram of this mass. I am sitting inside this lift. So the real force, that is due to gravity, mg, will be considered. All the real forces acting on this mass will be considered. From lift, I am considering a mg force downward. Now let the reaction between this lift floor and mass is n. So this n reaction by floor of lift will be exerted on this mass. By floor of this lift, a reaction, normal reaction will be exerted on this mass. That is also real, that I am considering, sitting inside the lift. So this n is nothing but weight of this mass. The reaction between mass and floor of lift is weight of the mass. That is the definition of weight. Now as I am sitting in this reference frame which is accelerating upward with acceleration a, now I have to apply additional force, pseudo force m into a, opposite to this accelerating direction, that is in this direction. This was accelerating upward, So pseudo force will be downward, and this force will be on this mass, and this magnitude will be m into a. Again I will repeat. As I am sitting inside this accelerating frame, by virtue of this acceleration, I have to apply an additional pseudo force on this mass. Magnitude of pseudo force is m, that is mass of this block, into acceleration. This is the magnitude, and direction of this pseudo force on this mass will be opposite to this a, which is going upward. So I have applied this force downward. That is analogous to velocity, which we were considering in constant velocity frame minus v velocity. Velocity of frame, and that velocity has to be reduced from velocity of object. Similarly, minus ma. This is minus ma. A in this direction, so this is minus ma actually. So just make the free body diagram, then equalize the forces. We can say mg plus ma is equal to n. So n is equal to weight is equal to m into g plus a. So its weight of this mass will increase by force ma. If the lift is stationary, then this weight will be mg. Simple, its weight will be mg. When this lift accelerates, its weight is mg plus a. A has arrived an additional force, which is not actually acting on this particle, on this block, but it is generated due to motion of the lift. Just because lift is moving, hence Newton's law, lift is accelerating, hence Newton's law cannot be directly applied in this frame. To apply the Newton's law of motion inside the lift, observer sitting inside the lift, he has to use pseudo force, which is ma minus m on this object, and after applying this pseudo force, he can use Newton's law of motion, balance of forces, and all as he is using in ground. So that is the use of pseudo force when a frame is moving with a constant velocity, acceleration. So till now we have discussed frames moving with constant velocity and frames moving with constant acceleration. So with constant velocity frames, which are called Newtonian frames, Galilean transformations are applied and relative velocity have been discussed. How the relative velocity changes when we change our position from one frame to another frame which is moving with constant velocity. Similarly, we have discussed how Newton's law of motion changes when we change our position from stationary frame to a accelerating frame. In an accelerating frame, Newton's law of motion cannot be directly applied. After considering pseudo force, we can apply Newton's law of motion in accelerated frame also. So, in short, we can say for accelerating frame, Newton's law of motion are not applicable, and for non-accelerating frame, constant velocity frame, Newton's law of motion can be applied. Hence, constant velocity frame are called inertial frame and accelerating frame are called non-inertial frame.